Everybody. This video is going to talk about complex fractions. And even though they look a little different from what we're used to, at least compared to what we've seen so far, it's really just blending division of rational expressions with, adding and subtracting. Really what we have here is we have one rational expression being divided by a second rational expression. So I could rewrite this immediately as just 18p over 8p minus 2 divided by 4p squared over 4p minus 1. Well, and then from there, we know that instead of dividing by that second rational expression, we really want to think of it as multiplying by the reciprocal. So now we really have 18p over 8p minus 2 times 4p minus 1 over 4p squared. And then from here, we can approach it like our multiplication with rational expressions, right? We're going to try to factor everything we can and cancel out common factors between the denominator. So let's see what we get here. All right, going back through and factoring, the numerator of the left expression does not factor, but the denominator has a GCF of 2 that we can pull out. Okay, in our second expression, the numerator does not have a GCF, well, nothing other than 1, and there's nothing to factor out in the denominator, so that's it. So let's see what we have. All right, we have a common factor of 4p minus 1. Right, we could think of these as being in parentheses if you'd like. So these will cancel. Let's go ahead and rewrite what we have left and do a bit more reducing. So in our numerator, all that's left is 18p. And in the denominator, if I multiply the 2 and the 4p squared that are left, I get 8p squared. We can reduce 18 over 8. Let's see, if we divide both of those by 2, we end up with 9/4. And then p divided by p squared will leave us with a p in the denominator. So that is our simplified expression. Now this is a relatively easy one because the two expressions that we were dividing already were a single rational expression. Sometimes you're going to see things that look more like this, where that first rational expression is actually 2 that are being subtracted. And the one that it's dividing by in this case is a single rational expression. But we need to do some work in the numerator, what I have in that blue box on the top, to be able to actually subtract those and turn that into a single rational expression before we can proceed. So we need to get a common denominator. So if I'm looking just in the top here, and just what's in that blue box, my common denominator that I'm going to shoot for is 3x. So that means the first rational expression, the x over 3, needs multiplied by x over x, which is going to give us an x squared over 3x. And then the second rational expression here, the 3 over x, that needs multiplied by 3 over 3, so we get 9 over 3x. Right, and that's still all being divided by x minus 3 over x. So now again, if we're looking back just up into the numerator, okay, what's in blue, I can now subtract those two rational expressions. That would give me x squared minus 9, right, and we keep that same denominator, 3x, and that is being divided by x minus 3 over x. So now we have a single rational expression being divided by a single rational expression. Let's go ahead and rewrite this. We said if we're dividing, we would really prefer to multiply by the reciprocal. So let's go ahead and write it that way. All right, we really have x squared minus 9 over 3x being multiplied by the reciprocal of that bottom expression, which is x over x minus 3. So instead of dividing by x minus 3 over x, I am multiplying by its reciprocal. So again, we're back to just that basic multiplication with rational expressions. Let's factor and start canceling out common factors. So in my first expression there, I have a difference of squares, which factors into x plus 3 times x minus 3. Nothing to do in the denominator. And then the entire expression over here on the right, there's nothing that we can factor. So we can cancel out a common factor of x minus 3. We can also cancel out a common factor of x. So let's write what's left here. All that's left in my numerator is an x plus 3. And all that's left in my denominator is a 3. And that would be my final answer. Remember, those 3's cannot cancel out. All right, let's do one last example. Okay, this one's tricky. Both the numerator and the denominator need to have common denominators found so that we can combine those together, creating a single expression. So this is by far going to be the most challenging one. So let's kind of just break our work off into chunks, right? Let's focus on just factoring, or not factoring, but getting this numerator simplified, and then we can piece it back together. So what I want you to notice here is that the denominator of this second expression can have a 5 factored out of it, leaving us with an a plus 3. Right, so we can see, hey, both of these denominators a plus 3. I just need to get it so the left one also has that 5. So we have a 5 now being multiplied to the numerator and denominator. Well, now we can go ahead and add these together, right? 5a squared plus 1a squared gives me a 6a squared in the numerator over that common denominator of 5 times a plus 3. Okay, so that one's good. Let's do the same thing to the green box here. All right. We need to multiply the left expression by 5 over 5. We need to multiply the right expression by over a plus 3. So we get 5a over 5 times a plus 3 plus 1 times a plus 3 over 5 times a plus 3. So if we go ahead here, I don't really need this one, right? If I distribute it in, nothing's going to change. So if I add my numerators together, I'm going to get a 6a, right? 5a plus 1a, and plus 3, all over 5 times a plus 3. So we've done the legwork here, right? Let's piece it back together. So what we really have is 6a squared over 5 times a plus 3, and that's being divided by 6a plus 3 over 5 times a plus 3. So now we'll change it to multiplication by the reciprocal. Cancel out common factors of a plus 3 and 5. And then let's see what we have left. We are left with a 6a squared over 6a plus 3. All right, that is it for this video. Okay, these are pretty complicated. They can get a little messy. It's combining all of those skills with adding, subtracting, dividing, and multiplying rational expressions. These do take some practice. So let me know if you have any questions, and have a great rest of your day.